So chapter 1-6, which is about solving compound and absolute value inequalities, it's just another extension of the solving inequalities and the absolute value we looked at earlier. So what is a compound inequality? Well, it is there are two inequalities that are joined by the word and or the word or. So to solve a compound inequality, you must solve each part of the inequality. So for example, when x is greater than or equal to -4 and x is less than 3. So you've got this situation where the x that you're looking for can either be greater than the -4 or can be less than the number 3. So first you identify, let's look at this side right here. So the places where x is greater than or equal to -4 are right here. Here's the -4, you identify it. I colored it because it has an equal sign, so it can equal to 4. And then greater is this way. But at the same time, I need to identify the other part now. X is less than 3. So here's my 3. It's not equal to it, so it's an open circle, and less than. So where these two meet are right in between here. So the number you're looking for is going to be somewhere inside this area. It can be the number -4, but it can't be the number 3 or more. So what if I ask you to solve a compound inequality and they're both put together? That's okay, just split it up in two pieces. So if you notice, you've got this is one of the inequalities, 8 is less than 3y minus 7, or you have this other piece, 3y minus 7 is less than or equal to 23. So solve in the usual way for your y or x or whatever variable they give you. And so if you notice here, I kept the 3y on this side, I moved the 7 this way, so that became 15, less than 3y. So if I divide both sides by 3, you end up with y being greater than 5 or 5 less than y. Then on this side, we ended up moving the 7 this way. You end up with 30. So 3y is less than or equal to 30. So y is less than or equal to, we divide both sides by 3, you get the 10. So now, you could also have what's called a union. So when you gather things together, you unite them, you have a union. So the graph of a compound inequality containing the word or is the union of the solution sets of the two. So when I unite these two together on one graph, then I'm showing a union. And so here x is greater than or equal to 5. So there is a 5, color it in, and it's greater, so it's this way. Or the x that I'm looking for can also be less than -3. You've got the -3 here not colored because there is no bar, and x is less than is this way. So the x that I'm looking for is either in this area or in this area right here. So let's look at a few properties having to do with absolute value inequalities. So if you have the absolute value of any ax plus b, which is greater than c, remember you've got those two cases. So you have to be careful about splitting it up and looking at those two possible cases. And of course, if you have the absolute value of ax plus b less than c, then you know that your solution is going to be somewhere between that -c or the +c. So looking at some other ways of showing solutions and so on, we can use interval notation. This is a way to describe the solution, so the answer to an inequality. So if you want to say that x is less than 2, you could show that x less than 2 means you're going from the number 2, and you're looking for numbers that are less than 2, so that means you're going to -infinity. Because remember, there is no, what's the smallest negative number? We don't know it, right? So you can say that it's just going to -infinity. So this is a way of writing it. Now, if you notice the difference, this didn't have a little bar, so no equal, so I put parentheses. This has an equal, so this is why you put brackets then, because it means that it can equal to those, because it is a greater than or equal to symbol. So greater than, where are numbers greater than -2? Well, they go to the right, and so to the right is always +infinity. So you write it like this, you put -2, comma, +infinity. That is called interval notation. And your infinity symbol is just that kind of little sideways 8 with a little stick is to show positive infinity, you put a plus infinity symbol, and then to show negative infinity, you go with the negative and that symbol. So now let's look at some of the problems you're going to be dealing with in section 1-6. So here you see some of the things that I had mentioned when it comes to the word and of course or. So if they ask you to solve that by graphing that on a number line, first you need to separate the two pieces. They've done that here. And then of course they built the graphs here. So anything greater than 4 comes this way. So here they colored this side and it has the little equal. So they did color that in. Here, if you notice, the y is less than 7 part, there is no equal, so it's an open circle. And the y is less than 7, any number less than 7 comes this way. So where do they overlap? The overlapping part is right here. And so that is your solution set. All y's such that y is less than or equal to y and less than 7. And then you have some more examples to work on to practice that idea. Some of these have the work done there for you. I had already shown you this on my notes, so we will continue looking at actual examples. All right, so in your study guide and intervention, they're going to ask you to solve some, so I'll just do any one question. So let's just work on number 1. So I see that I have two pieces. I've got this part and this part. So I'm going to go ahead and write the two separate sides. So negative 10 is less than 3x plus 2. That seems to be one side. The other side is 3x plus 2 is less than or equal to 14. So I'm going to start by working on this side. It doesn't matter if your x is on the right or left side, but I know some of you like for the x to be on the left, so let's practice that. So then I need to bring this guy over here. So this term is 3x, it becomes a negative 3x. And then this is a negative 10, it belongs on this side, so I'm going to bring it over plus 10. So now what do I have left? I already moved the things I needed to move. I rewrite it. So negative 3x on this side, this already moved, is less than, this 3x moved that way, the 10 moved, so less than 12. So now I need to get that x to be by itself. Oh, there we go. I just divided by a negative. So therefore I flip this sign and here I get a negative 4 because 12 divided by negative 3 is negative 4. Then I work on this side now. This 2 moves over, becomes minus 2. So then I get 3x is equal to 14 minus 2 is 12. Divide both sides by 3. And I also get that x is, oh sorry, it's less than or equal to. So x less than or equal to 4. Notice how this one didn't flip because I did not divide by a negative there. So those are the two numbers that I have to graph. So the first one is negative 4. And on this one, I don't color it because there is no bar here. So the other number that I have to look out for is the number 4. But this one does have a bar, so I'm going to color that in. And so I know that the number that I'm looking for is bigger than negative 4 and at the same time less than 4. So greater than 4 is this way, less than 4 is this way, and that's where they meet. So therefore that is my solution. So now let's look at the 1-6 practice section. We'll just take any one of these questions. Let's look at number 11. And so we got to remember when it's absolute value, there could be two possibilities. X minus 8 could be the 3, or x minus 8 could be greater than or equal to the negative 3. So let's deal with these two situations. In this case, x would be greater than or equal to, I move the 8 this way, so that's plus 8. So that would be 11. Or I could also have the situation where if I move the 8 over here, I end up with x is greater than or equal to 5. And so those are the two numbers that I'm going to be looking at. Whoops, but I just realized there's something you got to remember to do here. Whenever you're dealing with the absolute value, this, because I changed to that negative, this symbol should have come this way. So there we go. So just make that fix. And so these are the two numbers that I'm dealing with. And so therefore, I need to find the 5, which is about here. And I need to find the 11, which is about there. They're both with the equal there as well with the bars. So they can be equal to that. So I'm going to shade both in. And we're looking at a number greater than 11 or less than 5. So we've got those two situations. So greater than 11 is this way, and less than 5 is that way. All right, so let's do one more of these since these are a little bit trickier with the absolute value. So in this case, let's do number 10. We would have two situations where we've got the y plus 5 could be less than the 2, or the other situation where y plus 5 is flip the sign greater than negative 2. So let's go ahead and solve for both of these. So y is less than, I'm going to move the 5 this way, so it becomes a negative 5. 2 minus 5 is negative 3. And here, if I move the 5 this way, it becomes a negative 5. So y could be greater than negative 7. So we look for both of these numbers. Negative 3 is here. Negative 7 is here. I'm looking for a number that is less than negative 3 or greater than negative 7. So less than negative 3 is here. Greater than negative 7 is here. And they meet in the middle.